Mga migs, welcome to Winnie Luna Nahiel Eduk channel on mathematics and other related topics. For this video, our discussion focuses on the present value in an investment, and this is one of the topics, one of the lessons of the subject mathematics of investment. First, let us have an understanding of what is this present value. The present value, PV, is the current worth of future sums of money. In other words, this is about knowing how much money must be invested today in order to have the target amount in the future. The formula of calculating the said present or present value is P equals F times 1 plus I raised to negative n, where the uppercase letter P is the present value and the uppercase letter F is the compound amount. And our I here is the nominal rate, and this n is the number of conversion periods. Okay? Now, I'd like to make this clear that in some other reference books, the lowercase letter n is not used. The lowercase letter t is used. But no matter what lowercase letter is used, the concept is the same. Now, the present value formula comes from the uppercase letter P equals the uppercase letter F times the quantity 1 plus I raised to n. Okay, let's have the derivation of the present value formula. As we know, our maturity value is this formula. The uppercase letter F equals P times the quantity 1 plus I raised to n. So this is our maturity or final value formula. Okay, from this formula, we have to solve for P. Now, we can divide both sides by 1 plus I raised to n in both sides of the equation because we have this goal to solve for P, and our P is at the right side of the equation. So, we can cancel 1 plus I raised to n at the right side of the equation. And what we get is the uppercase letter F divided by the quantity 1 plus I raised to n equals P. And since the orientation of our eyes is that, or it is the common way, or it is a presentation in most cases that the unknown is written at the left side. So we can interchange P at the right and uppercase letter F over 1 plus I raised to n at the left to be at the right. And if we are going to interchange, the equation still holds. And that is also because of the so-called reflexive property. Okay, so we have this one. And then this 1 plus I raised to n can be written as 1 plus I raised to negative n. And in that case, this quantity 1 plus I raised to n cannot be or will not look a divisor of f. Just like 1 over x, you can write that one as x raised to negative n. This one, let's have this one. If you have this 1 over x, you can write that one as x raised to negative 1. So this 1 plus I raised to n is written as 1 plus I raised to negative n. Then it seems or it looks a factor already. Okay? So we have this formula for the present value. Let's also understand what is meant by net present value. The net present value, NPV, is the difference between the present value of cash inflows and the present value of cash outflows. NPV is used in capital budgeting to analyze the profitability of an investment or project. NPV compares the value of money today to the value of the same amount in the future, taking rate of interest into account. If the NPV of a prospective project is positive, it should be accepted. However, if NPV is negative, the project should probably be rejected because cash flows will also be negative. Before we proceed, let us understand what are cash inflows. Cash inflow describes all of the income that is brought to your business through its activities. Any strategy to bring profits into the business. Maintaining a strong cash inflow will keep your business afloat and allow you to reinvest and grow your business as you cover general expenses. Cash inflow includes returns on investment, financial activities, proceeds from sales of goods or services, then interest built over time periods. So, understanding what a cash inflow is all about is very important in business because if the cash inflow is lower or less than the needed amount to keep our business in operation, that will be a disaster to your business. Okay, so when you engage in business, you must have an idea what a cash inflow is all about. Then, cash outflow. Cash outflow refers to all the expenses paid out by your business. Cash outflow includes any debts, liabilities, and operating costs, any amount of funds leaving your business. A healthy business maintains a positive cash flow by keeping flows from operating low and minimizing long-term debts. Cash outflows include operating expenses, liabilities, debts, long-term debts, reinvestments, annual interest rates. So this is what I'm talking about when with respect to cash inflow. So the cash inflow in a business must be higher than the cash outflow. Because if the cash outflow is higher than the cash inflow, there is going to be a problem. There is a need to supplement the cash inflow. And that is a burden to the business owner. So it is good that the cash outflow is lower than the cash inflow. Okay, guidelines in using NPV for decision-making purposes. Okay, we have here three headers. If, so we have the condition, then the meaning, then the decision. If the NPV is greater than zero, the meaning is the investment would add value to the firm. Decision, the project may be accepted. Okay, that is because doing that business or that investment would add value to the firm because it will highly or there's a high likelihood that the investment will gain. Now, if the NPV is less than zero, the investment would subtract value from the firm. So that's the meaning. And the decision, the project should be rejected. Okay, it should be rejected because if you take the project and the NPV is less than 0, then there is going to be a big problem for the business owner. If the NPV is equal to 0, the meaning is the investment would neither gain nor lose value for the firm. So our decision for that, we should be indifferent in the decision whether to accept or reject the project. This project adds no monetary value. So we are not sure. No, we are not sure if there will be a monetary value of the project to be added to the firm. So if I would be the business owner, I would refrain from accepting the project because there's no high probability that sooner it will give or it will gain money for the firm. Because at the first hand, you have the idea that the NPV or the net present value is equal to 0. So you are given the idea of what would happen. But if you are going to take the risk, it's up to the business owner. So there might be other reason why the business owner is taking the project. Okay, let's have illustration. Calculate the present value of 230,000, which is due in 3 years, with an interest of 12% compounded by annually. So in this problem, our future value or final value or maturity value is 230,000. Our nominal rate here, our J is 12%. And we have here the number of conversion periods, 6. That is because there are 3 years, then compounded by annually. So twice in a year. So our interest for every conversion is only 6% because this 12% is divided by 2. So the interest every compounding period is 6%. So following the formula, we have the uppercase letter P equals the uppercase letter F times the quantity 1 plus I raised to negative N. So all we have to do is substitute the uppercase letter F by 230,000. Then we have here 0.12 divided by 2. That is because we are going to get the interest per compounding period. Then raised to negative 6. Then this 0.12 divided by 2, that is 0.06 plus 1, that is 1.06 raised to negative 6. Now, you simply use a calculator. You press the number 1.06, then the button, the function x raised to y or y raised to x in your scientific calculator. Then press that function, then negative 6, this will give you 0.7050. Then multiply that one by 230,000, you will get 162,150. So this is the present value of a maturity value of 230,000 with an interest of 12% compounded by annually in 3 years' time. Next illustration. How much should one invest today at 9% compounded semi-annually in order to have 200,000 pesos in 3 years and 6 months? So this is similar to the first illustration. We have here the value of the maturity value F here, that is 200,000. Then our time is 3 years and 6 months. And since this is compounded semi-annually, so there would be seven conversion periods. And our number of conversion periods here per year. That is 2 because we have compounded semi-annually. Our nominal rate here is 9%. Okay, so using the formula, uppercase letter P equals the uppercase letter F times the quantity 1 plus I raised to negative N. Then after that one, substitute uppercase letter F by 200,000. Our nominal rate divided by 2. Then our number of conversion periods, that is 7. Now, 0.09 divided by 2, that is equal to 0.045 plus 1. So you have 1.045. Then use a calculator, press this 1.045, then the function x raised to y or y raised to x, then negative 7. You will get 0.7348. Multiply that one by 200,000, you will get 146,960. So this is the amount you need to invest today for you to have 200,000 in 3 years and 6 months compounded semi-annually at 9% nominal rate. Another illustration in which we are going to apply our idea, our knowledge about net present value. We have here, based on a projected sales and cost, the project of company A expects that the cash flows over the 5-year period will be 200,000 in the first 2 years. So, first year, 200,000. In the second year, 200,000. 400,000 in the next two. So, in the third year, 400,000. In the fourth year, another 400,000. And 500,000 in the fifth year. This is over a 5-year period of investment. It will cost about $1 million to begin production. The rate of interest is at 10% effective. Compute the net present value. Is the project a worthy undertaking? Okay, so all we have to do is calculate first the present value by discounting the cash flows. That is, so we have to apply the formula of present value. So we have here 200,000 times 1.10. 1.10. Okay, that is because there's a single, or that is good for 1 year. Okay, so 1.10. Then raised to negative 1. Then 200,000 times 1.10 raised to negative 2, plus 400,000 times 1.10 raised to negative 3, plus 400,000 times 1.10 raised to negative 4, plus 500,000 raised to 1.10 raised to negative 5. Then you will get 1,231,300. So this is the present value, the present value of the investment, in which it costs $1 million to start the business. So the net present value is equal to 1,231,300 minus 1 million equals 231,000. That is positive. So that means this is a worthy undertaking. This project would add value to the firm. So it's good to accept or to have this business. This result is positive based on the value of NPV. The project is worth undertaking. I hope you got something from this presentation.